Hello aspirants, this is Rohit and today I am going to show you how to easily calculate the hybridization. This video is highly recommended for those going for the competitive examination, going after JEE, Neet and all of that. Not for those who are preparing for board examinations. Please do not try these tricks there. Basically, these are not the tricks, these are the way of understanding how to calculate hybridization with a basic method. So what is that method? I'm going to show you how to apply it, how to easily get hybridization of any molecule. So first of all, we have to see what is the central atom. After that, how many number of atoms are attached to the central atom. Then the lone pair present in the central atom. Here if we see as per the example of methane, that is CH4, here the central atom is C because in most of the cases the central atom is the one which is in minimum number in the molecule. Here in this case the hydrogen has four atoms and the carbon has only one atom. So easily we get the carbon is the central atom. On the higher platform, if we see, we will see that more than one elements are there which have a single atom present in the molecule. So further on we will see how to see this. First of all, for beginners friendly, we have to take this easy example. So number of atoms attached on the central atom are 4. Here 4 hydrogen atoms are connected, so the number of central atom carbon attached are 4. Now the lone pair. How to calculate the lone pair? It is the very easy method here of the central atom. Electric configuration of the carbon is, but it has total of how many electrons? It has total of 6 electron because its atomic number is also 6. So the configuration we see 1s2, 2s2, 2p2. So 4 more electrons can be accommodated in the p orbital because it can accommodate more or maximum of 6 electrons. So 4 more electron can accommodate. So it will have valency of 4. So the valency of carbon atom is 4. Now how to calculate the lone pair? The lone pair is calculated by valency of the central atom minus the electrons shared with the atom with the atoms which are attached to it. Like here in this case 4 hydrogen are connected to carbon. So carbon will share its 4 electron and the valency of carbon is 4. So 4 minus 4 is 0. How easily we get the lone pair? So after we get the number of atoms attached on the central atom and the lone pair, we will simply add both of them and from there we will get some number, as in this case we get the number 4. So what we have to do is now how to see the hybridization. What is it? Like sp, sp2, sp3, sp3d, sp3d2 or sp3d3. First of all, we we have to be aware about the fact that after sp3 there will be no hybridization like sp3, sp4, sp5 because the p orbital can contain maximum of 3 electron pair. So yes, after sp3 we will get sp3d. So let us continue what we are doing. Now according to a number like 2 is there, so 2 orbitals like s and p, and these are not only the orbital, these are now hybrid orbitals. So yes, for 2 we'll get sp, for 3 sp2, for 4 sp3, and for 5 sp3d, and for 6 sp3d2, 7 sp3d3. Now the easiest how to calculate the geometry. It is very easy formula to calculate the geometry. It is not basically the formula, it is easy thing how to calculate. We have to see how many hybrid orbitals are there. If 2 hybrid orbitals are there, so we have to arrange those 2 hybrid orbitals such that there is minimum repulsion between them. So in case of sp there are 2, so how to place them? We will place them one on this end, one on this end, so minimum repulsion will be there. So this is what is structure, this is a linear structure. So for sp we get linear structure. Now for sp2 there are 3 hybrid orbitals. So for that, in that case, what will we get? In that case, we will get sp2, and this structure, that is trigonal planar. Trigonal planar, because it is on a triangle. It is like, so on plane these two are there, and from top the triangle is there. So this is triangular planar. For sp3 there is tetrahedral, means one is here, one this, one bond this, one bond this. Now these structures are made such that there is minimum repulsion between the atoms that are attached and between the central atom. So the tetrahedral is done. After that is sp3d, like five orbitals, five hybrid orbitals are there. We can place them like in a triangle. We can place 3 bonds, and then one from top, one from bottom. This will complete the number 5. So yes, we get the structure trigonal bipyramidal, because one pyramidal is this from top and one this from bottom. So this is bipyramidal and triangular. So this is so easy, no need to memorize the name of the geometry. Okay, then the next thing, for sp3d2, for sp3d2 one square is there. So this is what geometry? This is octahedral geometry. Don't confuse it with number 6. If number 6 is there, then it would be hexa or something. No, for 6 this is going to be octahedral. Remember, this is octahedral. Now the last one is this one. So as we compare these two, so what we see, that here we took a triangle and one from up, one from bottom, 2 pyramids, because here the number was 5. Now here the number is 7. So can we do something to increase the molecules on plane? Here 3 molecules were there in the plane. So can we put here 5 molecules? Because if we will put here 5 molecules, then one from top and one from bottom will make 7. So this is so easy. And what shape is this? What shape is this? This is a, what shape? This is pentagon. This was triangle, so this was named trigonal bipyramidal. So this is pentagon, this one is pentagon, so this is pentagonal bipyramidal. So easy to remember the structures. And yes, this is the one more question that is asked most of the time, that what is the geometry of a molecule and what is the shape. So please, this is a very important point. You have to get hold of this, that it is never like the geometry is equal to the shape. It is only when the lone pair amount is 0. Like in the case of CH4, we get lone pair 0, so the geometry will be equal to the shape. And in that case, the geometry will be what? In case of CH4, what will be the geometry? Let us see that also. CH4, like CH4. What is the hybridization? We just calculated the hybridization is 4 are connected, so number is 4. So sp3 is the hybridization. So sp3 is the hybridization. Now here we see sp3 is here tetrahedral. We have no need to calculate this. We need not to learn the geometry. We have to see number of the molecular orbital. So that case is 4. Number of the orbitals, the hybrid orbital are 4. So it will be like one here, one here, one here, one here, and in between central atom C. So this is H, this is H, this is H, this is H. So this is the simplest way to draw the geometry. And this thing is the geometry. This whole thing is geometry, and as well as the shape. Why this is geometry plus shape? Because lone pair is 0. In the case of CH4, lone pair is equal to 0. As simple as that. If it will be not equal to 0, then geometry is not equal to shape. That we will further on learn in next videos, and I will make other videos based on the responses I'll get on this video. So please like, subscribe to my channel and share this video to your loved ones, those who have some difficulty in learning hybridization. I'll make it crystal clear in your minds. So thank you and have a nice day ahead.